Okay, so this is our last theorem. And it's the same side interior angles theorem. And we're still dealing with parallel lines cut by a transversal. So we're going to still deal with the same two angles, same two lines, L and M. We know they're parallel. And let's go ahead and get right on here. And they're being cut by a transversal. This time we're talking about the same side interior angles. So interior, we've done, this one's 2, and this one was 1, and this is 4, and that's 3. So let's go ahead and call this one 5. So are those two congruent? Because everything else has been congruent, so it just seems reasonable that they'd be congruent also, but not so in this case. It's a little bit different because, as you can see in this picture, one of these is acute and one of them is obtuse. So they can't be congruent. It doesn't work. But what could they be? Now, if you recall, this angle 1, which is and angle 2, those two are congruent because they are corresponding angles. So let me go ahead and mark angle 1 right here. Those two, 1 and 2, are congruent. 1 and 5 make a line. So what does that mean about angles 2 and 5? Well, if 1 and 5 form a line, which means they are supplementary, then maybe 2 and 5 are. And it turns out that that's what is happening. So we would say over here, angle 2 and angle 5 are supplementary. I'm going to abbreviate. And I'm going to say the measure of angle 2 plus the measure of angle 5 equals 180, which is what supplementary means. And then I will, of course, type that up. So, if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. So we've got this basic thing happening here. So we've got these 3 theorems plus the postulate, and we'll get to that later. But again, the same side interior angles are not congruent. They're supplementary. Everything else is congruent, so it's pretty easy to remember. And we've got that. So we'll do one that does all of them together in just a minute.